Welcome. In this video, we're going to be looking at dependent samples, and so let's get started. First off, dependent sampling involves two samples that can be uh, related in some way. So either you're using the same set of sources or related sets to obtain the data, or they're connected. The two samples are connected in some way. And so one of the ways that I like to visualize this is that you have either a single sample where two variables are being measured from a single sample, such as a pre-test, post-test, or perhaps you have two related samples. Now, with independent sampling, you have two unrelated sets or sources that are used, one set from each population. And I like to visualize this like this, where you have two different samples and there's a variable that's measured from each of the samples. And there's sort of like a bar, a line, or a wall between the two samples. So there's no connection between the samples. They don't interact, no relationship. This is kind of like what you did for your project, or I guess what you're doing for your project this week, where you're comparing two samples. Perhaps you're comparing the some sort of like the weights of bags of peanut M&Ms with the weights of bags of plain M&Ms, or whatever it is, or but whatever you're measuring two different variables, or you're doing the same variable on two different samples. That's the key. So here's some examples of the dependent sampling. Dependent sampling could be a pre-test and post-test. Suppose we gave you a test at the beginning of this course and another test at the end of the course. Then each of you would constitute a member of the sample, and each of you would have a variable at the beginning and a variable at the end. You would be the connection between the two variables. Husbands and wives, oftentimes social scientists will do experiments or studies in which husbands and wives or people who are connected by a relationship will be compared. So if we're comparing the heights of men and women, it might make sense to compare the heights of husbands and wives, and the connection there is the marriage. So the thing connecting the numbers for the husbands, the men's heights, and the wives, the women's heights, is the marriages. So there's a connection between the men and the women. Some side-by-side product testing could be considered dependent sampling. If people are ranking or rating sodas at a taste test or something like that, that would be a side-by-side product testing. Now, over on the right-hand side with the two samples, it is possible to get rid of that big wall if you're clever about it. And the way we get rid of that wall is by doing what's called a matched pairs sampling. In matched pairs sampling, you pair up the samples according to some variable that you think is related to whatever you're studying. So for example, weight loss, you would match people up based on their initial weights. It doesn't make any sense to compare the amount of weight lost by a 300-pound person and the amount of weight lost by a 150-pound person. The 300-pound person has twice as much weight to lose as the 150-pound person. And so if you're going to match up two samples, maybe two different diet plans or two different diet drugs or whatever it is that you're comparing, it makes sense to match people up based on their initial weight. So you get two really fat people and you match them up. Two people that aren't so fat, and I guess I have to change my color scheme. Good enough. Sorry about that. At any rate, get two people that aren't so fat and match them up. So you get people that are the same starting weight. They're starting at the same level. So that gets rid of that wall and creates a connection between the samples. Some examples are students matched by IQ. Maybe I want to match your class with another class. So we could match up the students based on IQs. It's not fair to take someone who has a low IQ and compare them with someone with a high IQ. And so match people up. That way you're comparing apples to apples and oranges to oranges. Dieters can be matched by initial weight. And so here's an example of just such an experiment. We have the subject pairs. Students are matched by initial weight, and we've made one group of students. Now, this is a fictitious study, I should say, but it's based on a real life study that was done comparing weight loss due to dieting with weight loss due to exercise. Anyway, we match up students based on weight. We have one group try to lose weight by dieting and one group try to lose weight by exercising. And so you can see that the two 250-pound individuals, the dieter lost 40 pounds and the exerciser lost 50 pounds. And the 40 pounds is an admirable amount of weight to lose, but we're trying to compare dieting to exercising here as a weight loss technique. If you have an initial weight of 200 pounds, we have the dieter lost 20 pounds and the exerciser lost 30 pounds and so on. Anyway, I wanted to do this two ways. The first way is the way where we ignore the fact that there's a connection between the two samples just to see how that goes. This is exactly like what we did in the previous presentation, and so this will go through pretty quickly. So if we just did a plain two-sample t-test, we're not pairing it up this time. We'll pair it up in just a minute. You can fast forward if you don't like watching this or if you don't want to. Step one is the parameters. And the parameters are the average weight loss for dieters and the average weight loss for exercisers. That's it. The hypotheses, weight loss and due to dieting and exercising is the same, would be the null hypothesis. The null hypothesis always has an equal sign in it. And then they're not equal would be the alternative hypothesis. Average weight loss is what we're comparing. The distribution that we're going to be using is the t-distribution, mainly because it's because we don't have the standard deviations for these populations. We're going to have to compute them based on the data. I have my p-value here, but if you want to know where the p-value came from, I can show you that. I've got my calculator, and I've got my data. Here's the data typed into the calculator. Just go to Stat, go over to Tests. We're doing a two-sample t-test. And let's see, we're using data. List 1 and list 2 are where I put my data. Frequencies, I've got it 1. We're not pooling. Let's see, calculate. So you can go back to the other presentation if you want more information about this. But you can see here the p-value is, oh, it's not what I said on the screen here. Okay, so the p-value is 0.2148. I think I probably made a mistake back here. So you can see that I can make mistakes just as easily as you. Hopefully I catch mine though. I must have done something like this. Let's see if that gives me the, I'll bet this will. Yeah, there's that p-value. But that's a one-tailed test there. The mu1 is less than mu2. That's not what we had back here. It was that they're equal or not equal. And if we're going to match that, then when we go and do this hypothesis test, it better look like this right here. And that's what it should look like. So anyway, my p-value is 0.2148, or rounded up to 0.2149, which means that I accept the null hypothesis, and there is not evidence to suggest that average weight loss due to dieting is different from average weight loss due to exercising. Well, now we're going to go on and do this as if it was a dependent sample, which it is. This is a paired or dependent sample. And so to do this, what you're going to do is you're going to compute the differences between the pairs of data. Now here it's very important that you specify what you're subtracting. And so what we're going to be doing is you're going to test whether the average difference is equal to 0, or maybe if it's less than or equal to 0 or greater than or equal to 0. But you're comparing the average difference, not the averages to one another. So let's go ahead and do this. These differences, the parameters. Earlier we had these as the parameters, but now what we're interested in is this, the average difference between the weight loss for exercisers and the weight loss for dieters. And I need to emphasize this, that mu sub d, this average difference, is not the same as the average for the exercisers minus the average for the dieters. Now, it is very important to note that we're going to be doing weight loss for exercisers minus weight loss for dieters. That's how we're going to get this, but these are not the same thing. And in fact, at this point, we don't even, and you don't even need these two. You don't need to write those down. All we care about is mu sub d. Okay, so let's go on. Our hypothesis is that the average difference is equal to 0 would be the null hypothesis, and it's not equal to 0 is the alternative hypothesis. The distribution is t once again. We don't know anything about a standard deviation for the population. And now here again, notice that what I've got here is I have in this column here, I have the exercisers, and in this column, I have the dieters. And so I'm doing the exercisers minus the dieters. And I've kind of emphasized that here. You can do this on your calculator. I can show you how real quick. Go ahead to go to Stat and do Edit. And over here in L3, move up to the sort of the header, press Enter, and then you can actually type list 2 minus list 1, and it'll automatically take all the numbers from list 2, subtract off list 1, and put the differences here in list 3. Check it out. So there it is. It's the same stuff I have back here. I hope I got it right. Yeah, 10, 10, 10, and 20. Okay, so I just want to do a simple t-test. It's a t-test for these numbers. Now that I've got those numbers, those differences, I don't even need these anymore. I don't need the numbers in these first two columns. Those are extra. All I care about are those numbers now. So when I do this test, there's the p-value. Let me actually do it on here. Watch what I do. I do stat, tests, and I'm just going to do a basic t-test because I have one column of numbers that I care about. So it's just a single variable. I'm going to use data. Let's see, the null hypothesis is that the difference is equal to 0, so I'll put that as 0. The list I'm going to use is list 3. My differences were in list 3. And I think the rest is okay. Go ahead and calculate. And I guess I got it right this time. No, I guess I must have a typo here. This one I'll chalk up to a typo. 0.15, I'm sorry, it's 0.015392. I left out my 3 back here, but it's okay. It's close enough. It is less than 5%, and so I'm going to reject the null hypothesis. And in this case, there is evidence to suggest that the average weight loss due to dieting is different from the average weight loss due to exercising. In fact, specifically, the average difference between dieting and weight loss is not 0. Let's take a look at another example. In this example, a composition teacher wants to know whether a new grammar program will reduce the number of grammatical errors her students make when writing a 2-page essay. She has 6 students write a 2-page essay, and then administers the new grammar program, and then has the same students write another 2-page essay. We're going to use alpha is equal to 0.025 to see if we can conclude that the number of errors has been reduced. So we start off with the hypotheses. I suppose I left off my parameter. My parameter is mu sub d, and mu sub d in this case is the average difference in errors before and after the grammar program. And I believe what I've done here is I've done before minus after. So we want to specify that before minus after because it'll affect this, especially that particular hypothesis. Notice that if, in this case, I'm saying that my alternative hypothesis is that the average difference is greater than 0. That makes sense if I'm doing before minus after, because if the before has more errors and the after has fewer errors, then before minus after will be greater than 0. Anyway, I've got my hypotheses. I at least spoke my my parameter, but make sure you write down your parameters for all of these problems. And then let's go ahead and do our calculations. We need to do those differences, and those differences are pretty easy to compute here. You can use your calculator if you need to. I've got the differences now here. I'll just type those into my calculator. Well, I did it earlier, and so those differences are all I'm going to type in. And what I get is I end up with, where am I? Oh, here they are. So there's the differences. And then I use just a plain t-test. And there's what the input looks like. Notice that I'm using the greater than mu0 because my alternative hypothesis was that mu was the mu sub d, the average difference, was greater than 0. Anyway, I go ahead and calculate, and here's what my output is. My output is p is equal to 0.03779. And for that reason, I'm going to reject the null hypothesis. And the conclusion is that there is evidence to suggest that spelling errors or grammatical errors decrease as a result of this grammar program. That's it. Feel free to watch or please do watch the technology videos for more information on how to use your calculator.